Alangar, HL7's Director of Education. Welcome to what promises to be an interesting discussion. Our highly experienced and knowledgeable speakers this morning are Chris Lindop and Shuja Dasgupta. Chris has got over 22 years of healthcare industry experience as a systems and interoperability leader with focus on workflow and interoperability standards. Shuja has got over 15 years of experience in developing and designing healthcare products. He currently leads the interoperability and imaging practice at CTS Tech. At this time, I'm going to invite Shuja to start the discussion on why CTOs need enhancing imaging workflows, the emerging trends, and new interoperability standards. Shuja, over to you.
Thank you, Swapna. And good morning, good evening, everyone. Thank you for joining the webinar today. As a part of the webinar objectives, some of the key takeaways we hope that you'll have by the end of the session today is to sort of understand the challenges that are faced in emerging workflows today, especially as we look at enhancing and to meet emerging workflow requirements. This is predominantly based on new workflow needs in imaging workflows with connectivity to HIE systems like EMRs, operationalizing AI at scale, and the role that some of the newer standards can play in enabling this. We also plan to discuss the role of FHIR adoption, specifically from an imaging standpoint, and some of the collaboration work that is happening between DICOM and IHE to accelerate the adoption of FHIR. The third item we wanted to cover today was to talk about how we can gain insights into trends that impact the deployment and some of the new healthcare standards that are going to come up, and what is the regulatory trends that are going to play a role in accelerating the adoption of some of these standards. Moving to the next slide, it kind of gives you an overview of the landscape of interoperability standards in healthcare today, particularly from an imaging standpoint. We start with an overview of what are the standards we're using in healthcare today. So the three main standards that we're using in imaging today are DICOM. DICOM has been, of course, around since the early 1990s and is current avatar of DICOM 3.0. And it's a very mature standard, but it was predominantly designed for data and communication exchange using a point-to-point connectivity, which is TCP/IP driven. There's been a recent enhancement to add DICOM Web, which has now been integrated into workflows as well. HL7 is used heavily in the imaging space today to supplement DICOM. We're looking mainly at handling non-imaging data through HL7-based transactions. So orders, reports, admission, discharge events, etc. And this is also based predominantly on top of TCP/IP-based standards. The third is IHE. IHE has gained traction as the workflows became more complex, and there was a realization that we need. Yes.
So I think there's a lag in. Okay, now we are seeing the overview of standards used in imaging systems.
I see.
Thank you.
No problem. Right. So the third standard we are seeing today is IHE. So IHE plays a role as a workflow standard and it's used heavily to manage workflows which involve multiple actors. Right? So how do we define what is scope of DICOM that's been implemented, what's the scope of HL7 that's been implemented to be able to handle transactions between different actors in an imaging ecosystem. And more recently, we're looking at FHIR as there's a gradual movement towards API-based standards. It's not widely used in imaging workflows today, and that's one of the items we're going to discuss over the course of this webinar. So some of the challenges that we face today, as I move to the next slide, is as workflows have evolved, as the needs of clinical systems, imaging systems have evolved, we're finding that there are still a lot of silos that exist in imaging ecosystems today, right? So for example, a lot of the imaging data tends to be centralized around the PAC system, while a lot of the clinical, the supplemental clinical data that's needed around lab information, patient history, etc., tends to be either at the EMR or it's hosted in a separate system. So how do we design workflows around addressing this? there tends to be a fair amount of fragmented information. So in addition to having silos, we also tend to see information in fragmented pieces and also an inconsistent representation of the data, which has led to challenges. And that again impacts how it can be integrated at a holistic workflow level. Fundamentally, imaging data itself tends to be quite heavy. So we are seeing that there are imaging systems which where image data itself tends to be megabytes of data, right? So how do you managing that again at a workflow level, integrating that can pose its own challenges. We also have
slides haven't changed, Suja.
Yeah. I'm sorry, I'm having a little bit of a connectivity issue. I'm sorry, I'm on slide number 4. Suddenly encountered a small internet issue. Hopefully it should change soon. I'm on slide 6 of the deck. If I could just maybe pause, share my screen again. Is it visible now, Chris?
Yes, slide 6 is showing.
Okay, great. So again, the interoperability piece that I was just referring to, which was around managing some of the data. Also, a lot of time is, as we sort of move towards more customized workflows, there's a lot of time spent in integrating different applications, which requires complex integrations, which tend to be site-specific. So that's another sort of limitation we're facing today. And all of this sort of leads into inefficiencies at a workflow level, which again creates a problem to integrate new actors and integrate new technology standards, given the limitations of the historical context in which some of these standards were designed. In the next section, we sort of discuss some of the current trends that have come up in the imaging space today. So I'm moving to slide number 8 of the deck. So at emerging, some of the emerging interop trends that we're seeing, right? And these are broad themes that we're seeing in imaging today. The first is around the movement towards creating a real-time access to a set of both imaging and non-imaging data in the context of specific patient encounters or patient visits. So a few themes that have come up around this area are based on vendor-neutral archives. So how do we design vendor-neutral archives have gradually gained traction in the industry today, and they're intended at addressing this problem. So how do you integrate imaging data with non-imaging data? And also some of the problems that you have in terms of managing proprietary data, consistent representation is implemented at as a part of the vendor-neutral archival workflow. The second is common viewing access. So how do we provide access to imaging data from non-traditional systems? So historically, a lot of the imaging interpretation has been done in a reading room setting. But as you move towards a scenario where you may have the need to view imaging data on your mobile, you may want to view it in your tablet. There may be newer workflows around referrals, around secondary opinions that need to be supported. How do we evolve or extend standards to support this as well? And the third is around creating imaging exchange, right? Which is around, again, there's numerous efforts that are taking place here around building out clinical document exchanges, building out newer IHE profiles for image access for interactive sharing of studies. There's the initiative with Care Quality and RSNA for enabling a framework for image exchange, and also using the cross-document sharing profiles, such as XDS, for again enabling information exchange. So there are multiple efforts which seem to take place, which are taking place in parallel around implementing this. Another trend we're seeing is sort of the movement to an API-based format. And Chris has been a very active participant in some of these discussions. And I'll request Chris to sort of share his perspective on these topics.
Yeah, well, one of the key things here is the DICOM Working Group 20, which is also a joint working group in HL7. It's the Imaging Integration Working Group. Primary goal of this group is to really, synergize the two standards and to ensure that they interoperate. As DICOM really focuses primarily on imaging, the entire clinical workflow is actually more towards the HL7 domain. So trying to make sure that we have, as one of our roles is to ensure that the information content that's in DICOM is seamless going through the through the HL7 realms. Primarily, one of the the imaging, the image study, and some of the other FHIR references that have been developed, as well as some of the some of the basic fundamental standards. Even with V2, we've worked quite a bit with trying to ensure that there's a common integration point of the information that's provided to imaging and the information that comes out. A lot of what we're working on today is really focused on getting the getting the workflow from orders to results, making sure that we have common data elements that coincide with that are usable. Not only within the imaging realm, but actually when we go post-imaging into the reporting domains, that's one of the areas that we focus on. And certainly, it has been instrumental in moving things forward, especially with the DICOM web and the FHIR initiatives that both these groups have put together. So as we see, coming in the future, what are we going to be working on? We'll see a lot of work on structured data. You'll see a lot of work on basic overall workflow for imaging.
Terrific. And I think as we've worked through some of the trends that we're seeing here, right, in terms of API-based integration around building out sort of centralized repositories of information, we feel that there is a similar need to build out standards for AI, especially from the integration and workflow standpoint, in parallel to the core engineering and development activities, so that we don't run into the same type of issues. And that's one of the areas we'll get into more detail as we move through the webinar. The other trend that we've been seeing, right, and this is sort of a little bit outside the realm of imaging, but at CTOs Tech, we work exclusively in the healthcare technology space, and we are sort of seeing trends towards standardizing the adoption of FHIR, right, across HIT systems. And there were 2 or 3 key trends we've seen over the last few months, which will have a meaningful impact, in our opinion, of how FHIR will be implemented going forward. Right? So the first piece was around the CMS Interop blocking rule, which essentially came up with a mandate around streamlining the data exchange of FHIR using a standardized representation. The representation of FHIR was actually captured under the 21st Century Cures Act, which was an update to the 2015 rule that was published by UNC, and which in turn updated the common clinical data set usage with USCDI, which is a new structured data representation. And these, the CMS rule and the 21st Century Cures Act sort of complement each other well. The CMS rule lays out a framework for payers for data exchange, which sort of mandates the usage of the 21st Century Cures Act. The 21st Century Cures Act in turn plays a role in laying out a framework for standardizing the API as well as the implementation of FHIR and resources that need to be exchanged, and also sets a baseline time frame by which this needs to be achieved, along with a spectrum of data that will need to be made available. And again, USCDI plays a role in implementing that. So in our opinion, as we've kind of moved through working with different standards over a period of over the last few years, across the healthcare spectrum, one of the biggest drivers for consistent adoption of standards is regulatory guidance, right? And that's one of the reasons, we've seen MU1, MU2 adopt so fully, right? And the ubiquitous use of EMRs in clinical ecosystems today. And what the 21st Century Cures Act has done, right, is that it's laid out a clear timeline by when these implementations will be made available to the public. what is the information that's made available, right? So that's another sort of big piece in our mind, right? That as you're going through your implementation cycle, making decisions on how you want to implement FHIR, how do you get, how do you have confidence that as a consumer of a FHIR API, as a consumer of certain information, that information will be made available to you, and you're able to abstract your implementation from the underlying EMR or HIC system that you want to communicate with. Each of these topics, the CMS rule, the Cures Act, and the USCDI representation is actually a topic for a webinar itself. CTOs Tech had actually done a few sessions on these in the past, which are available on our YouTube channel, and we have some webinars which sort of explore these topics in more detail further. But what we tried to do was, based on this assessment, we wanted to extend this out into understanding how this would impact downstream imaging systems if you decided to use the USCDI representation as your baseline for consuming non-imaging data to supplement what you have today, right? So today, a lot of the EMR connectivity tends to be very specific. There are data brokers that are commonly used. There are specific integrations with APIs that are exposed at particular EMR level. If you're able to abstract that away and create a well-defined time frame and representation that could be used, and have a sense of the data that would be available, what would be the impact on imaging workflows as a result? And this is sort of the timeline over a 2-year roadmap of how this will be laid out. There may be some small variance in this due to COVID-19 impacting the ability of HIT vendors being able to take it up, but at least at a high level, there's been no change on this so far. USCDI, as I mentioned, is the sort of the replacement for the common clinical data set, and it extends it out a little bit further. So this is what you see on the right is the version 1 of the USCDI framework, which lists out the information that will be made available to consuming application. And a couple of important themes, which again have an impact on almost any system that will integrate using this approach, but particularly from an imaging system standpoint, will be around the alignment with FHIR Release 4, the need for standardized APIs to exchange data, a well-defined timeline based on the final rule that was published in May 2020. There will also be, as the definition of what qualifies as enterprise level patient data expands, as the definition of what EHI expands, this rule may be expanded to include additional parameters. And we will also look at how the information blocking piece also ensures that the data will be made available to consuming systems. So this is sort of the assessment that we use, and we said based on this subset of information, what is the impact that you're going to have on downstream imaging systems that we see? So keeping this in mind, right, we kind of looked at what is the impact on FHIR adoption as a result. So we looked at what is the need for imaging, what is the role that it will play in terms of integrating imaging systems with external health IT repositories. What is the impact that it can have on providing access to patient data at point of care and at the point of review or interpretation of images. The integration that will play, as you know, there's a general movement towards API-based standards and including new devices into the ecosystem. And also the role it will play in standardizing the data flow of information to complement the imaging information that's available today as your AI ML actors that are built into the workflows get more advanced. So at a high level, right, in addition to the data structure, the data representation based on the regulatory guidelines, there are also incremental guidelines around authentication, around access to data, which are defined within the ONC guidelines, which play an important role in streamlining integration. This allows a lot of information to be made available at a PACS level, which in the past, while it was available, it would supplement, while it was available, it requires a high degree of customization at a workflow level. The other piece where we felt that the FHIR guidance that has been provided will complement the sort of enhancements in imaging today was it doesn't really represent imaging data per se. That is still captured under the ICOM web, but it serves as a good complement to how these standards are evolving. And as the workflows get more integrated and streamlined, the end-to-end workflow of how you sort of share imaging data along with non-imaging data and create a standardized, consistent representation of how this will be passed into downstream algorithms and imaging systems will allow you to deploy some of your AI solutions at scale, right? Which again has been a slight challenge where we are trying to find ways to integrate AI actors into sort of workflows which are comprised heavily with legacy actors. And at a platform level, this is kind of how we visualize or imagine this moving forward, right? So you would have the ability to take imaging data, couple it with clinical data, integrate it into harmonized data, and then drive in workflow intelligence downstream. So you would see things like a common use case we'll discuss is workflow prioritization, support for clinical decisions, providing access to expert cases, expert references based on incremental clinical information that is available during the interpretation process, and also smartness in your real-time and notification events. And eventually, this in turn can provide a platform to building out a strong innovation framework, right, which looks at precision medicine, looks at treatment planning, looks at disease management, which is a more holistic view of the overall imaging pipeline. So this is sort of the high-level assessment that we had done in terms of how imaging standards in IHE and some of the USCDI enhancements will impact imaging workflows today. And what we tried to do was also talk to certain clinical experts in terms of how this would impact their activities today, right? If we were able to provide this data. And we have a brief demo around this as we go through the webinar. So a couple of things that, again, we will spend a little time on is the recent IHE profiles that have been developed, which basically cater to AI, and also some of the impact of USCDI and FHIR and imaging today. And again, integrating AI into imaging workflows continues to be a huge focus area for our imaging systems today. So what we are looking at from AI and imaging standpoint is the ability to integrate AI into the overall clinical imaging workflow. We are also looking at building out the effort that, some of the challenges that we've seen with the first wave of AI algorithms as they're getting integrated, both from image interpretation and assessment standpoint, and also the workflow optimization piece. Right, so in order to deploy especially AI at scale, right, the need to build new standards in parallel to these actors is going to be extremely important. One of the profiles that we'll discuss in a little more detail is the AIWI profile that Chris has actually helped author. And it talks about how AI actors will need to be integrated into the workflow. We're also looking at catering predominantly non-interactive AI models, and Chris will kind of discuss that. And also the need to provide access to data from an EMR standpoint, right? So as we look at standardizing the integration with EMRs, right, and how it will both play a role in enabling operationalizing AI at scale as the algorithms and the workflows mature, and they will, as there's an anticipated need for some of these algorithms to continue to build out in order for them to function, we feel that they will need access to real-time historical patient data to be able to come out with more specific actionable insights, and also the role that the role in terms of expanding EHI and the role that this information will play in terms of driving imaging workflows as we move into the future. So with that, I'll request Chris to talk a little bit about some of the IHE radiology profiles in 2020 and how these have been advanced over the last few months. So Chris, over to you.
Oh, thank you. Thank you, Sergio. Okay, so IHE is it's a joint initiative between users and vendors to profile use cases, clinical use cases that are applicable to the real world so that products can be developed and very easily integrated to solve these real world issues, clinical issues. The two profiles, IHE has many domains. One of the domains that is radiology. And this 2020 cycle, we have really an 18-month cycle that we work on profiles, but they all begin within, they all begin usually in the, the second quarter of the previous year, or 2019 is when we started looking at these profiles, what profiles that we want to be working on, and focus on selection of profiles that we believe are going to be most applicable to today's issues. What we have come up with is two profiles specifically targeting AI workflow for imaging and AI results. The goal, of course, of the AI workflow for imaging is really to standardize the workflow and results distribution between the different systems. In the marketplace today, in the market, you'll have many systems which many analytics, AI analytics systems, which can solve unique problems. And they all have their own basic requirements of imaging data and, and as well as clinical data, what they need to be, what they need to do their job. Hence, we need the ability for a system to do the orchestration of these different AI algorithms. And so we've targeted the workflow to specifically hit, those systems that will be requesting the workflow, those systems that will be managing the workflow, those systems that will be performing the workflow, and then when we get into the AI results, those systems that actually be consuming what these AI analytic software provides. So as you can see, the AI results, you'll have, we've got to have a standardized storage and common method for the results to be displayed for image interpretation, as well as if you characterize the results, we'll want to ensure that if there's any actionable findings, that they are, they're redirected to whom needs to see them most, such as reading Worklist prioritization and other uses as well. Next slide, please. So let's look at AIW and the scopes. It's a little bit more detail. We wanted to ensure that we had a profile that was very simple to implement and common to implement that meets the needs of the environment today. So our target was to detail the workflow with the actors and the steps. We focused primarily on non-interactive use of the AI models, and that's kind of key. We wanted to start simple, make sure that we have the most the largest framework for adoption. Certainly, with the extent that in the future we'd be able to, possibly next year to start bringing interactive use case models into the fray. And we really focused on, from the AIW, the classification, the classifying models, looking for the presence of a condition, and ensuring that we, if there is a condition, that it's properly outputted to the right system for action. The key things that we wanted to ensure is that that if the framework was put in place, we wanted to ensure that the AI models that we're going to be able to to be managed by an orchestration system are able to be very simply plugged in. So let's move to the next slide. Next slide, please. In IHE, we abstract the capabilities into actors, very fundamental basic actors. And so that's, AIW is no different from any other one, but they have a fundamental role. So one role would be the task requester, the one that actually initiates the request for inference. And we've defined a specific transaction for doing that. The other one is the task manager. That's the one who receives the inference request and then assigns the inference request to a task performer, which would be an AI model. And they're the ones that actually perform it. The goal is to ensure that they have the information that they need, and that would be ensured by the task manager as well as the task requester, which should be gathering that information. The other profiles, the standardized profiles that you'll see throughout the IHE radiology in particular would be image manager. That's where DICOM data is managed. That's where the images come from. We've added the procedure reporter, and in the spirit of how IHE works, if your system conforms to a procedure reporter, it could be, could be the task performer, it could be the task manager, it could be the TAD requester. It's a secondary, or it could be something, a system entirely different. Wherever you want to put the logic in that would be looking at the results or has the results and identifies that there's an actionable event here, that would be the one that would gather that data and of course pushes it off to a report manager, which manages the reading worklist. Next slide, please. So let's talk briefly about a couple of the different actors, and this one in particular is the task requester. And as I said, this is the one that initiates the workflow. And really, there's one fundamental thing that it has to do, and that's create that inference request. We're using UPS work item, and the UPS, which is DICOM standard, by the way, it's a RESTful standard, so it's a fairly simple interface for other systems to really consume. It provides a location of image data and non-imaging data, giving FHIR endpoints. It will also tell you where the results are posted, as well as it gives you an idea of what specifically it needs to be done. But those are the key things that the task requester would do. There's also this capability of watching. So just because you basically request, you can request and forget, or you can request and get information, provide updates. So, by opening up a channel, a WebSocket, you can essentially receive update notifications. Once you've sent it out, you'll get an update that the work item has been assigned. You'll get a progress report of when it's complete, and where the content was actually stored. Those would be the fundamental things. And of course, when we look at who's going to be implementing a requester, quite about anyone who has images would be a requester. A common integration point is a PACS VNA, but another common point is actually an acquisition modality or a risk system or any other departmental workflow manager that needs to have this work done. Next slide, please. I'm going to go over all the profiles. This is just a quick summary, and if you want to highlight, and certainly we can provide you more information on the details of the profiles, both profiles, the AI results as well as the AIW profile. But one of the key things that we felt necessary was that these AI models will sometimes provide information that would have actionable, actionable findings that need to be worked on in a very timely fashion. So, given the fact that we're in today's environment, not everyone's doing HL7 FHIR. We wanted to make sure that we had a standardized mechanism for distributing basically an update to the procedure. And such we'll use an OMI message or an ORM to convey the status, not only the status change, by using an OBX segment, including the AI qualitative findings. And within the OBX section, you'll find the actual findings categorization, as well as the abnormally flagged, and how a system is going to react to that is really left up to the system managing the reading work list or the EMR that's going to get that information. But it has the information encoded, and the key thing here is that this is what we're identifying is a common structure, a common method for reporting this content from an AI model. Next slide, please. Now back to you, Sia.
Great, thanks. Yeah, so I think one of the use cases, if I could just go back one slide for a second, right? When we talk about the reading worklist prioritization, this was a fairly common use case that we were seeing, and this was several demos related to this at RSNA, right, where you were looking at reprioritizing a worklist based on the findings of an AI algorithm, right? So if you had a patient with a stroke condition, and that the worklist needed to be reprioritized based on that. This is something we saw quite commonly at RSNA and at CHIME. Now, when we actually went into trying to deploy some of these solutions in the field, one of the areas where the lack of standards impacted us, right, was while it was possible to come up with a specific integration, right, that allowed you to reprioritize a worklist, right, without the framework that Chris had outlined here, because it was not being managed or orchestrated at a workflow level. There was nothing to prevent the worklist from being reprioritized 5 minutes later by some other entity or some other algorithm, right? Because it wasn't a harmonized approach. So while it worked in sort of a discrete action or a discrete term, there was no way to, primarily due to a lack of standards, to be able to orchestrate the workflow that we could ensure that, while even if the worklist was reprioritized, it was also persistent. Right. So I think those were the type of use cases that sort of had enabled us or gave us an indicator that we needed to work on building out standards in parallel to as we were reworking some of the workflows instead of leveraging solely being dependent on existing transactions driving some of these scenarios. So with that, as we look at as a quick summary, right? We look at the USCDI piece, the data elements that are now being made available to us, and also the standardized integration approach that it enables, right, in conjunction with what you're seeing from ONC. So we're talking mainly about EMRs, but this could be any certified health information system, right, that needs to be compliant with these systems. So potentially this could be modules on lab systems, etc. But we focus on the EMR use case as a part of the initial assessment. What this also will do, right, is once you have a well-defined approach for FHIR and how you want the data to be represented and structured, the same approach can also be extended out to downstream actors, right? So if I'm receiving my data in a USCDI compliant format, and I now need to propagate that to a downstream system where I have an incremental integration that I need to manage, there is a very strong recommendation that you would want to persist the format, right? Especially given that there is a strong regulatory push around adopting that format. So it'll give us a very consistent implementation and representation of the data as we look at integrating more actors into consuming this. And again, just in our experience, this has been a challenge, right? Where we've actually gone and tried to implement or integrate this at a production level and at a site level, and it's been a problem for us to run it because there are different approaches and there's a certain amount of flexibility to the underlying implementation. There's been a sort of inconsistent integration or implementation experience, right? So it's been a bit like working with HL7, right? Where you do need to come up with more site-specific customizations when you're trying to access specific data elements, right? And based on the assessment we've done so far, we think that the recent trends we're seeing on the ONC CMS and USCDI side will help alleviate and mitigate some of the challenges we're facing there. And once this is in place, this will allow us to, again, create a streamlined data exchange pipeline all the way down into operationalizing AI algorithms at scale. So what we wanted to do was, as we worked through this scenario, we actually had a demo that we built out where we took a specific case history for a patient as a scenario, and we worked on this with a set of clinical experts to see how this incremental information would be able to help them, right? Assuming we were able to provide it in context. So the case we took was for the procedure of a 72-year-old patient who presented at the ED with a history of emotional distress, palpitations, and a history of blackouts. And once they were examined, there was a request done for ECG, a blood test, and a 2D echo. And when we presented the demo, what was the typical viewing viewer application, right? Where typically you would only see the imaging content unless there was specific custom integration with to provide historical lab data. The interpretation was limited to what was displayed on the imaging viewer, right, which was around ventricular hypertrophy and thickened mitral wall. And the assessment was very open-ended. So what I'll do is I'll just switch over to the demo that we had planned, and I'll just pull that up. In the case of what we're describing here, as I mentioned, right, this is the result of the 2D echo that was taken. And this has the left ventricular hypertrophy, this is the bilateral atrial dilation, and the thickened mitral valve. But what we learned, right, as we worked through the assessment, is there are several other clinical parameters where if we could provide that at the point of image interpretation, that would aid the assessment, right? So what we tried to do was create a framework based on the USCDI elements that were available. So we came up with a structure that represented at a high and mapped the classes to what is available at a USCDI level. And based on the procedure that was conducted here, we were able to highlight what were the clinically relevant parameters in the context of the procedure that you're seeing here. Okay? So what we're seeing is, with the incremental data that's available, right, we have information related to the evaluation note, which was the patient history. We have data related to the smoking status, which is of course important in the context of the application for any cardiac assessment that was done. Things like the height and the weight of the patient, right, which would indicate that the patient was clinically obese, right? And again, information related to the systolic and diastolic blood pressure, right, which again would play an important parameter. And because this data was implemented with a structured data representation in mind, we were actually able to display it in the context and display the most clinically relevant parameters at the top of the worklist. So things like the cholesterol levels of the patient, the HDL, the LDL cholesterol. played an important role in terms of coming up with the assessment, right? So you can see that there is the cholesterol provided, the normal range is indicated. And based on these parameters, we were actually able to come up with a much richer interpretation and a set of the next steps available for the patient. So what we tried to do here was, again, there are a whole host of parameters, including things to do with ethnicity, with race, etc., which are all sort of mapped to what we had seen in the USCDI data classes. And what this ended up in doing, and I'll just switch back into the main application for a second, the demo for a second. So what we saw over here, right, was this was the image interpretation broadly remained the same, but the additional data that was available, right, was one that the patient was classified as clinically obese. The patient was a former smoker. The patient had certain, comorbidities, which would play a role in hypothyroidism. The patient was diabetic based on the UB, the HbA1c parameters, the hypercholesterolemia based on the lipid profile, and similarly additional risks, right? That could be the patient blackouts could actually be linked to transient ischemic attacks, which is equivalent to stroke. And based on that, the end user that we presented to was able to come up with a much richer assessment on what was provided. So when you looked at the 2D echo findings that were mentioned, right, we looked at the additional comorbidities around the risk, for atherosclerotic disease and the risk for a heart attack for the patient. And similarly, the recommended actions that were provided were much more specific as a result, right? And again, for the purpose of this, this didn't require a custom integration, didn't require going through data adapters, building out an integration with the EMR custom based on their APIs and the type of data they provided. This allowed us to be able to take the data set representation as is. We were able to build out the data representation in the context of the procedure that was conducted, right? Given that there's a structured data representation. And based on the findings that were provided over here, we were able to provide a color Doppler, recommend a color Doppler to look at the blood flow analysis, the Doppler of the neck and MRI vessels, recommend a coronary angiogram, and also specify an endocrinology result, right, based on the incremental clinical data that was made available in the context of the procedure that was conducted. And this, at least in our opinion, ended up debottlenecking a whole bunch of the challenges that we had encountered, at least in our prior experience of managing these type of integration. So the other sort of piece I wanted to check on before going into the Q&A side of the discussion was we actually did this with in the context of the cardiac application. So this is what you see over here. We also extended this out to a couple of other scenarios, which I don't think we'll be able to go through in detail today, right? But just from a mammography standpoint, we again use the same USCDI based approach, but what we tried to, the parameters that are clinically relevant to a diagnostic mammography procedure are very different from what is relevant in a cardiac procedure. So in a mammography procedure, the family history is an extremely important parameter, right? So if you look at the relationship that you have with any family members who are genetically predisposed to cancer, it's a very relevant parameter. Certain gene mutations would be considered extremely relevant, as well as incremental lab results that would be done, lab tests that would be done for a mammography procedure. The ability to display this in context of the procedure because of the underlying structured representation adds a lot of value and improves overall clinical interpretation. And again, while a majority of the information is codified, some of the integrations that you're seeing here and some of the values that you're seeing here can further be supplemented by AI coming in, even just on what you're seeing on the panel on the left, right? Being able to review unstructured clinical history, having smart NLP, and then be able to drive workflow steps, right? So you could use this as a mechanism to build out smarter reports, to highlight certain parameters in the context of the clinical case, and essentially improve the end-to-end throughput of of the entire review procedure by building this. The last I wanted to highlight over here was for the purposes of this integration, right? We actually did an integration with the Epic sandbox that you're seeing out here. So Epic has sandbox with their USCDI implementation, and where you can actually go into the sandbox, you can actually manage the integration. For the purpose of this demo, because we wanted to actually treat it against the real world implementation, we actually went to their, you can actually go into the sandbox, you can do a search on certain lab parameters. And the parameters which are USCDI compliant are highlighted over here. You can actually go in and look at the patient over here. What we found was, one is, of course, you're able to get access to the USCDI parameters, right? If you look at the, one of the parameters we showed, right, which was around the HbA1c count for the patient. The data is represented in a consistent, unambiguous format, which is codified, right? So you look at the coding scheme, you look at the unit of measure, you look at the parameters that are provided as a part of the range of values, right, that you're seeing over here. So this is the range that was specified in the representation that we received from the Epic sandbox. We were able to see the value. And again, the fact that it comes in a codified representation allows us to automate the workflows, right? Because there's no ambiguity in terms of interpreting the content of the data. So that is, I think, was a big driver for us. And especially if you look at building out automated workflows that are going to be dependent on this data, getting the data in a consistent, unambiguous format is going to be a critical aspect of that, right? So the degree of customization that we would encounter would go down significantly. The other piece, of course, is that for the purpose of the demo, we went with Epic, but any system which is providing a consistent representation of data, which is aligned with the structure outlined in the USCDI framework, can be interpreted in this way, right? So in some respects, as a downstream HIT application, I can decouple my implementation from APIs that may be specific to the HIT vendor, to the EMR itself, right? And that again removes one of the sort of big bottlenecks that we have experienced in terms of managing these implementations. So at a high level, this is kind of what we wanted to walk through. And again, I will just switch back to the presentation, and we'd be happy to take any questions that the audience may have on these items. I know we've received a couple of questions in the chat window, right? So I think one of the questions that we took up was around how USCDI ties into the imaging framework. So I think the way we had viewed it, right, was we viewed as complementing the image data. So if you look at the earlier trends that we had seen in imaging, right, the ability to provide access to a broader set of clinical data within the context of traditional imaging systems, we feel that there is now a pathway to be able to do that without a high degree of customization and implementation work. So I think that was one part. I don't know, Chris, if you wanted to add anything related to this.
No, I think that's good.
Excellent. Another question that we just got, right, was the Epic observation is in DTSU2. So right now this is in Epic sandbox. There is a roadmap towards moving to DTSU4. The Epic has not committed to a timeline to be able to do that, and traditionally that's been one of the problems that we've seen. Yeah. But if you look at the overall EHI timeline that's been provided in the ONC Cure, the 21st Century Cures Act, that's a really important sort of frame of reference for us, right? Because I'm no longer dependent on a vendor-specific implementation to move me towards a specific, to make the data available. There is a regulatory roadmap in place where there are actually fairly severe penalties associated with systems that are not compliant with this. So they will not be certified as EHRs, and that has an impact on the MU1, MU2 incentives that these systems get. So, and also just based on sort of the macro trends that we are encountering and the type of discussions that we are having, there's significant investment being made in moving and complying with the regulatory framework that's been outlined over here. Chris, again, I just want to see if you had any inputs on this.
All right. So, would you like me to answer some of the questions?
Absolutely. Yes.
Okay. Well, so the last one coming in, has the AIW been finalized for the IHE Connectathon? And the answer to that is yes. It's actually it's actually should be published, officially published by the end of this week. And it's so it's been finalized, and it's gone through the publication cycle. The only thing that's left is for IHE, the IHE International Group to who's in charge of publication to put it out on the web. So and when that's done, the actors will be there for testing in the upcoming connectathons. I would also say the other places to look at, we've been doing a lot of interim testing and sample data, is it was with the CIME and actually the CIME hackathons, as well as it could easily be tested at if there's interest to work in the the upcoming in the upcoming FHIR Connecticon, because these are basically interconnected from that perspective. When you get to the standards, and that's to the standards, it's and the restful standards, especially between imaging and non-imaging systems. This is one of the key convergence points that we should be looking at. What else could we talk about?
There was one more question available on the Epic test server. So yes, there is a sandbox available, from Epic to be able to,
The Epic, you got to realize that's a question to Epic, and we really are not, we're not in a position to answer questions other than what we know of that's publicly out there.
Yeah.
So, okay, so how do we manage custom codes? I'll answer another question. How do we manage custom codes at the level of providers? So IHE does have a profile shared value sets, which could be used to manage non-standardized codes as well as standardized codes, and that would be an approach to how you would share that data between systems. Other than that, yes, the profiles are extensible to standardize to localized codes. The issue would be the distribution of those localized codes, and that's where I would say look at SVS to distribute the codes sets.
Excellent.
And
I think we've gotten to.
Look, I think we've gotten to most of them. Where can we sample? Where can we test them? Like we said, the places to test, the places to sample, the connectathons, the IHE connectathons, as well as CIME hackathons, and we certainly could look at what we could do in the FHIR connectathons as well.
I think we're right at the top of the hour. So again, I just want to thank everybody for their time and hand it over to Sadhana.
Yep. Excellent discussion. Thank you so much, Suja and Chris. Thanks everyone for your questions. You made the presentation really interesting with all your questions, and it was quite an interactive session. Thank you so much, and till we meet again, I hope you join us in one of our future events or future classes. Till we meet again, bye everyone. Bye, Chris and Suja.
Thank you.
Thank you so much again. Thanks again.